Well, I'm missing you guys terribly, but I know you're just loving Miss Bryant, so I hope everything is going well. Well, I'm going to do a couple of the problems from your homework tonight that I thought you might find a bit challenging, and I was also a little nervous that you might take an easy way out on these, so I wanted to make sure the directions were super duper clear. Okay, so this is problem 3B on the back of your worksheet, and you have to prove whether this function is continuous and differentiable, or continuous not differentiable, or neither. So let's first take a look at continuity. Now we know for continuity that there are three conditions that it must meet in order to be continuous. And the first condition is that the value must exist. So the value at 0 must exist. Now why am I only considering 0? Well, because when we look at this first piecewise, we see it's a quadratic, and we know quadratics are continuous within its domain. This is x cubed. Cubics are also continuous within its domain. The point of concern is where the two meet at 0. Is it continuous and differentiable at 0? So the value exists. Now this is the important piece actually for a piecewise, is the limit as I approach 0 from the right of the function. Well, what is that limit? So I look at the first piece because that's coming from the right, and that value when I substitute 0 is 1. And then what is the limit as I approach 0 from the left of this function? Well, from the left I plug in 0 and I also get 1. So we can see that the limit does exist and the value does exist the limit, so therefore this function is continuous. Okay? And really this is what you need to write as your work to support continuity. And then you could say, yes, the function is continuous. Now let's check out differentiability. Okay, now at this point we know how to use the definition of differentiability to be able to figure this out. Now I'm going to need a little more space, so I'm going to erase this. Now you may want to do your work on a separate sheet of paper because there's not much space on that worksheet. Okay, so here we go, differentiability. So what I'm going to look at first is I'm going to look at the differentiability of the first piece. So I'm going to see if the derivative of the first piece, what is the derivative at the first piece as when x is 0? So it's the limit, the derivative is the limit as h approaches 0. Now for this first piece, a lot of times what I like to do is I like to first find the values. So we know that f of 0 is 1, we've already established that, and f of 0 plus h, that will be used in the numerator. And so it would be, oh, I didn't leave myself space, I'm going to go below. So it's the quantity x squared will be replaced with 0 plus h. So it's 0 plus h squared plus 1. Oh, well, that's not so bad, is it? It just turns out to be h squared plus 1. Great. So the definition says we do f of 0 plus h, which is h squared plus 1, subtracting it from the value at 0, which is, 1. And then it's all over. And then we go 0 minus 0 plus h, which just leaves us with h. Okay, so let's do the mathematics. Now make sure that you keep writing the limit as h approaches 0. This is the derivative each time until you've substituted 0 into the function. So we have h squared over h, and then the h's reduce. So the derivative of f as the limit of h approaches 0. So we end up with h. Now we'll substitute 0 in. So the derivative of this function when x is equal to 0 is 0. Now let's check out the derivative of the other piece. Now the other piece is x cubed plus 1. So now I think I'm going to need some more space, right? But I need to remember the derivative is 0. Actually, I can just add a new page here. Okay, here's my new page. So the function I'm investigating is x cubed plus 1, and I'm looking specifically for the derivative at 0 of this function. So first of all, I'm going to find the value of 0, and the value of 0 is 1, and then I'm going to find the value of the function at 0 plus h. Well, we replace x with 0 plus h, so it's 0 plus h cubed plus 1. So that comes out to h cubed plus 1. Okay, now I'm going to use the definition derivative for the derivative at 0, and it's as h approaches 0. So it's going to be f of 0 plus h, which is h cubed plus 1, subtracting the value at 0, which is 1, all over h. So now we're going to do some reducing. So the derivative at 0 equals the limit as h approaches 0. So we can see the 1's reduced out, h is reduced out, so I'm left with h squared. So the derivative, when I substitute 0, is 0. So that means the derivative from the left and the derivative from the right is both equal to 0. So therefore the function is also differentiable. So would you like me to do one more? You don't have to watch if you don't want to. Okay, let's see. I will do, which one do you want me to do? E? Okay, let's do E. So E. So E, we are given the piecewise f of x is equal to x fourth minus 2x squared, where x is greater than 1, and then we have negative 1, where x is less than or equal to 1. Ooh, I'm glad I picked this one. So first of all, we have to establish continuity, because if the function is not continuous, then we know it is not differentiable, and we can stop. So first condition of continuity, does the value at 1 exist? And the value at 1 would be negative 1. Now, the reason why I'm considering just 1 is because the first piece is a quartic, which we know is continuous, and the second piece at negative 1, that's just a horizontal line, right? So that's also continuous. Now, let's see if the limit exists at 1. So first we check out the limit from the right of 1, so that's the first piece. So it's going to be 1 minus 1, which is just 0, and then the limit of x as it approaches 1 from the left is negative 1. Did I do that right? No, I didn't, because I'm like, wait, on my scratch paper it comes out continuous. I made a mistake, folks. Yes, you know it happens frequently. Here, let me erase it. Oh, my eraser won't come up. There it goes. Oh, where is that eraser? I tell you, I need an iPad. Okay, eraser. Okay, you know what, folks? I'm just going to cross it out. This is wrong. So let me redo it. The limit as x approaches 1 from the right, I substitute 1 into the function, and I get 1 minus 2 times 1. That's where my mistake was. So it's negative 1. So we can see then the limit from the left and the right is equal, and then we can also see that the limit does equal the value. So yes, the function is continuous. Now let's prove differentiability for each piece. So I'm going to... Okay, now let's find the derivative of each piece. So the goal is to find the derivative at 1. And the first piece we're going to investigate is where the function is equal to x to the fourth minus 2x squared. Okay, so I like to find the value at 1 first, and then the value of 1 plus h. So the value of 1 we already figured out is negative 1. Now the value of 1 plus h, so wherever there's an x, I'm going to replace it with 1 plus h. So I'm going to have the quantity 1 plus h to the fourth. Oh no, that's going to be brutal. And then 2 times the quantity 1 plus h squared. So let's expand 1 plus h to the fourth. You know, that's a lot of expanding. And as I'm looking at this problem, I am noticing that I have a 1 plus h squared in common. So I'm wondering if it would be easier to factor out the 1 plus h squared and then multiply. Now, I gotta tell you sometimes, guys, sometimes I see things and I do it, and actually it's longer than what if I would have just normally done it. But, you know, that's kind of the fun of it. Okay, so I have 1 plus h squared times what would make 1 plus h to the fourth? Well, that would be 1 plus h squared, and then minus 2. So let's go ahead and now expand. Now, all I have to deal now with is squares. So I get 1 plus 2h plus h squared. Notice I'm trying to write really neat. Okay, now that's being multiplied. Again, 1 plus 2h plus h squared minus 2. Okay, so what I'm multiplying is two trinomials. 1 plus 2h plus h squared times a quantity, 1 plus 2h. Oh, I forgot to subtract my 2. Well, that's easy though. Negative 1 plus 2h plus h squared. So let's multiply these trinomials. So 1 times negative 1, oh boy, this is going to be a beast. Negative 1 plus 2h plus h squared, and now 2h times everything, minus 2h plus 4h squared plus 2h to the cubed. Woohoo! Having a party yet? And then minus h squared plus 2h to the third plus h to the fourth. Wow, don't make a mistake on this. Now let's combine any like terms, or better yet, let's see if anything reduces out. Let's see, my h squared and my negative h squared, my 2h and my negative 2h, I think that's it. So now I'm left with, how many cubics do I got? Oh, let's do the fourth first. H to the fourth plus 2h cubed plus 2h cubed is 4h cubed. And let's see, 4h squared plus 4h squared minus 1. Do you guys all agree? H to the fourth plus 4h cubed plus 4h squared minus 1. Okay, so now I know I'm going to take, this is my f of 1 plus h, and I'm going to subtract it from the f of 1. And that's going to be all over h. Okay, now I'm going to go ahead and erase here because I want to keep this, well, actually I can just go to the next page. Okay, so we're going to add a new page. Okay, so the derivative, so we're finding the derivative, oh, I need to get back to pencil. The derivative of this function at 1 is equal to the limit as h approaches 0. And remember, the value at f of 1 plus h is h to the fourth plus 4h cubed plus 4h squared minus 1, and then we're going to add 1 because we're subtracting a negative 1 all over h. Well, we can see those reduce out, and then we can also reduce out an h. So the limit as h approaches 0 for the derivative of the function at 1 is, so we now have h to the third plus 4h squared plus 4h. So now when I substitute in a 0, the derivative at 1 is 0. Wow, that was quite a bit of work to find that. But hey, we did it. Don't give up. You never got to quit. Well, that's not how the song went. Anyways. Okay, so now let's find the derivative of the other piece. Now the other piece is the function x equals negative 1. And we want to find the derivative at 1. That's our task. Well, you might say, Ms. Kleiber, how do I replace 1 plus h in negative 1? Well, actually, you don't. Let's just think about this logically. So this function is negative 1. What type of line is that? Well, Ms. Kleiber, that's a horizontal line, right? What is the slope of this line at negative 1? Well, the slope is 0 on the whole function. So the derivative of this function at 1 is 0 also. So now we have just proven that this function is both continuous and differentiable. Love it.